Hi everyone, good day. This is Dr. Von, and for today we will be discussing about your urine smear preparation, reading, and reporting. I know you already heard about the news of your limited face-to-face finally. And you know what? This topic will be easier, mas easier siya na madidiscuss when we had a practical examination because it's a lot easier. You will really understand how to properly read and how to properly report when you are using your microscope and you are doing the actual urinalysis. But right now, for now, just try to understand so that during our limited face-to-face, we will still discuss this one, but somehow you already had the idea. Okay? Sige, see you next, hopefully next, probably next month. Very excited. Okay, for today's discussion, our reference book will be still your Strasinger, your 6th edition, and your Brunzel, Urine and Fluid Body Analysis. Again, almost the same lang sila ang content pero mas detail lang yung ating Brunzel. But you can still read your Strasinger, okay? This is still our main reference book. So our learning objective for today, at the end of this video lecture, the students are able to learn the correct way of preparing urine smear for microscopic examination. Again, if you cannot prepare the correct way of making a smear, then there could be an erroneous result, most especially in reading and reporting your urine sample. Identify the different urine sediments that must be reported in low power field and high power field. Identify the different urine sediments that can be reported in qualitative terms. Again, different urine sediments, they will have different ways of reporting. It could be by means of a range, by means of a quantitative description. So that still depend now sa protocol ng hospital. But then again, we still have to follow what is in the book and what is ideal. Kasi nga, you are still training, right? And also, accurately report your microscopic examination of your analysis. This is our main objective for today. You will be able to correctly make a microscopic examination of urine correctly. Report correctly. So this will be our topic outline. First, your specimen preparation, your specimen volume, the process of centrifugation, the sediment preparation, the volume of sediment being examined, and examining the sediment, and lastly, how do we report your microscopic examination. So again, as a review, when these are the different steps in your analysis, you already discussed your specimen collection, your sample verification, your physical exam of urine, chemical exam of urine, microscopic examination of your urine. So basically, tapos na kayo dito lahat. Tapos na kayo until microscopic. Now, my part here is the release of the results. So before we could do now the releasing of results, you should be able to correctly read and report your urine sediments. So, ano ba ang correct way of making the report? So again, still our discussion is still part of the microscopic examination of your urine because you cannot read and report without doing the microscopic exam. So still part of this one, and if ever you will be able to accurately make a result, then that's the time that you can release now your result. So as a review, this is an example of your urinalysis report. You already know how to make a report sa ating physical examination, right? I discussed this one, the color and the appearance. The chemical examination, you already been discussed on how to make a correct report. And lastly, my task here is the microscopic examination. You already been discussed by Sir Kuday on how to identify these different urinary sediments. Now the question is, how do we make the report? So example of this one, pus cells of 0 to 1 per high power field. So bakit may 0 to 1? Bakit hindi siya total counting? So later on, we will understand what is the correct way of reporting these sediments. And also, mucus thread, bakit nakalagay few? Are we not going to report that or count that, doc? Why not 0 to 2? Same with your pus cells or 0 to 1. Again, different urinary sediments will have a different ways of reporting it. Okay? Sige. At least you are now familiar with this type of urinalysis result. Most probably sa face-to-face natin, you are the one to fill out everything here. Physical exam, chemical, and microscopic. Because this is really the bulk of AUBF. Ang kabalo mo, unsaon pag report sa urinalysis. Okay? So first, let's talk about your specimen preparation. So specimen, how do we prepare a specimen? Or what would be the most ideal specimen used for microscopic examination? Again, your specimen should be examined while fresh or adequately preserved. So emphasize natin yan na fresh urine. So when you receive your urine, as soon as possible, you have to read the result. And again, before collecting that, you emphasize na midstream clean catch, di ba dapat yung ating specimen? Why? Because it minimizes the external contamination of the sediment. Again, we prefer fresh over refrigerating our sample because, number one, if you're going to refrigerate your sample, what will happen? It can cause precipitation of different urinary sediments or crystals, such as your amorphous urates, your amorphous phosphates. And what will happen if there will be precipitation of these crystals? Then there could be obstruction or ano nangyari? Na-obscure yung ating different urinary sediments. Therefore, we will have difficulty reading later on. And also, Doc, sige Doc, we will refrigerate. Why not? We are going to warm the urine sample as soon as possible. If you're going to warm it at 37 degrees Celsius, what will happen? It may dissolve your other crystals. So again, it will also lead to false negative results. So that's why we prefer a fresh sample over refrigerating it or warming your specimen. So again, emphasize ko talaga, fresh sample. Specimen volume. Again, for the specimen volume, a standard amount of urine, usually 10 and 15 ml, is centrifuged in a conical tube or test tube. What we use in the laboratory are your test tubes. So between 10 to 15, average of around 12 ml. So ito yung ginagamit natin na sample because this will provide an adequate volume from which to obtain a representative sample ng ating elements present sa ating specimen. And a 12 ml volume is frequently used because multi-parameter reagent strips are easily immersed in this volume. So remember your chemical testing. So if you have an adequate amount or most probably 12 ml, it's a lot easier to dip now your entire reagent strip. And also, if for example, the patient cannot provide a 12 ml sample, for example, your pediatric patient, the volume of your specimen must be noted sa ating report form. Again, these guidelines is based on the book, but that will also depend on the hospital protocol if you really need to report it. But ideally, ako personally, when I receive a sample of less than something 12 ml, less than 10 ml, or what, I always ask for a repeat collection. I always do repeat collection, but that will still depend on your patient. Kung pediatric patient, you still have to check it. Pag check mo, somehow there is a correlation with the diagnosis of the patient, then might as well release the result. Okay? But again, that will still depend on the hospital protocol or laboratory protocol. Centrifugation, okay, so you can do 5 minutes at a relative centrifugal force of 400. So this setting will provide or produce an optimum amount of sediment with least chance of damaging the element. So mas prefer natin to 5 minutes at 400 RCF kasi nga less damaging sa ating mga elements. And remember that the speed of your centrifuge and the length of time of the specimen should be consistent. Kasi nga, we do not want to do damage sa ating mga urinary sediments. For the sediment preparation, a uniform amount of urine and sediment should remain in the tube after decantation. Then volumes of 0.5 or 1 ml are frequently used. So again, you have your test tube, diba? You already collected around 10 to 12 ml sa ating test tube. Then you have to decant. And after decantation, ang usually na natitira na lang dyan is around 0.5 to 1 ml. Then you, what you call this one, you flicker it, you mix it, resuspend it again, and yan yung ating ilalagay sa glass tube. Usually, anong nangyayari sa mga student when we ask na, sige, after centrifugation, na-centrifuge na natin yung ating sample, urine sample, tapos sige, you decant it. So, pag i-decant lang, simple lang, itatapon lang natin sa sink, and then, ang natitira, that's the part na ating babasahin. So, if i-flicker natin yung natitira, and then you mix or resuspend, ilalagay natin sa glass slide. Pero, ang nangyayari sa mga student, natatakot sila. Okay? When they decant or tinatapon nila urine, pagtapon nila, agad-agad binabalik nila kasi akala nila wala nang matitira. Again, automatically, huwag kayong matakot. You just decant it. Kasi matatapon na talaga ng lahat. Do not worry, may matitira din. After a few seconds, ibalik mo yan. Then may matitira pa yan na supernatant. Then you mix that with the sediment. And then you flicker. Then yung lalagay sa ating glass slide. Okay? But however, what is being reported or the ideal setup talaga is meron silang ginagamit na commercial system. Sige lang, i-discuss ko lang tong commercial system na to. Kasi sa commercial system, yung supernatant is being aspirated off rather than poured off. Diba? Usually, pinupour lang namin. Pero, there is a commercial system that to maintain the uniform urinary sediment, the supernatant should be aspirated off rather than being poured off. So, some system provides a pipette for this purpose. This is the most ideal, but we do not have this kind of commercial system. The pipettes, yung ginagamit nila na pipettes are used for sediment resuspension and transferring of your specimen to your slide. Okay? The sediment must be thoroughly resuspended by gentle agitation. So, you can flicker. Ito yung sinasabi ko na dapat i-flicker natin, resuspend natin, and then, again, because this can be done by a commercial system or by the tips of your finger. If you flicker lang natin or by tapping the tip of your tube. And then, you do not do a vigorous agitation because it will disrupt some cellular elements. So, nadi-disrupt yung other elements, so nadi-destroy sila. So, therefore, we will not be able to get an accurate reading later on. Thorough resuspension is also essential to provide equal distribution of elements in the microscopic examination fields. Again, there must be a thorough resuspension. So again, dapat yung sediment na na-form natin sa ilalim, dapat mag-suspend siya sa buong naiwang supernatant para equally distributed siya when we do the examination later on. Okay? So, this is now, ito yung sinasabi kong commercial urine sediment preparation system. Kasi nga atin, hindi ganito, test tube lang. Ganito lang, test tube. Pero ito, this is not a test tube, but this is a specialized nga CUVA na meron siyang, may graduated siya, no? May graduation siya. So, again, atin ginagamit usually in the laboratory is just test tube. Test tube lang. Wala tayong ginagamit na pipette and all. But this is the most ideal commercial urine sediment preparation system. So, ito yung tinatawag natin na CUVA system. Ano pa yung CUVA system, Doc Von? So, this actually consists now of your CUVA tube. Ito yung number 2. This is now your CUVA tube. This is your CUVA petor. So, ito yung pipette, specialized pipette na sinasabi natin. And this is your CUVA cup. And then, the clear plastic centrifuge tube, ito, is filled to the appropriate graduation mark with a well-mixed urine and is cup. So, dito natin nilalagay yung urine, yung average na 10 to 15, and then tatakpan natin ng specialized cup. And then, after centrifugation, your designed CUVA petor is gently slid into the tube. So, ipapasok natin siya dito. And then, at the end, until to the base. So, nakita nyo until the end of the base. And itong bub-like structure na ito, it will cause now, 1 ml of urine can be easily, the bub-like structure here will fit snugly. And then, such that all but 1 ml of urine can easily be decanted. So, in short, this is one way of parang alisin yung decantation. First, makukuha natin yung sediment, dito mapupunta yung sediment, and then you can decant now the remaining fluids here. So, nakukuha natin yung ating sediments dito, and then yung fluid natatapon natin. And then yung natirang fluid or yung supernatant, imimix naman natin siya imimix natin siya dito so that we can now prepare for our urinary, for our urine smear later on. Again, We do not use this one. I never tried. Hindi pa ako nakakita ng ganitong system. What we usually do in the hospital lang, test tube, tinatapon lang natin. Yung natitira, imimix lang natin, i-resuspend thoroughly. Yan yung ilalagay sa ating glass slide. You can really do this when we have our face-to-face limited face-to-face. Sige lang, tuturuan namin kayo, okay? But at least you have the idea that we have this kind of system, no? Personally, itong gina-workan ako, I was able to do my internship sa SMMC. Wala silang ginagamit na ganito sa, tawag nito sa, work ko dati sa Digosloc, wala din kami ginagamit ito. Simple na talaga. Centrifuge lang yung test tube. In terms of the volume of sediment that is being examined, the recommended volume is 20 microliter. 20 microliter, which is covered by a 22 by 22 millimeter glass cover slide. So this is the most ideal volume na ating babasahin, di ba? Fini-flicker natin yun, mini-mix natin yun. So kukuha lang tayo ng approximately 0.02 ml. Allowing the specimen, and also, hindi ko masyadong preferred magamit ng cover slip kasi ang nangyayari, pag masyadong maraming sediments kung nilagay, nasi-spread out yung mga malalaking sediments such as your cast. So, anong nangyayari? Doon na siya, doon pupunta sa kilid ng cover slide yung ating mga cast. So, sige lang, may experience yan. Pag sobrang dami. Kaya nga, ang ideal volume lang dapat is 0.02 para hindi siya mag-exceed sa ating cover slide na, cover slip. Hindi siya pupunta doon sa kilid. Okay? Dapat exact amount. So, ako personally, through time and experience, no, wala yung ko naka-cover slip. But again, you are still training, you are still learning. We still have to do what is ideal. You still have to do the guidelines based on the book. But later on, no, through your practice, you will be shocked that based on the hospital protocol, it's really different from what is presented in the book. Kasi nga, this is now based on clinical experiences. So you learn from your seniors. Sometimes your seniors, they have these clinical experiences na that sometimes they modified what is on the guidelines, they modified the procedure, but you can still give an accurate, fast and accurate result. So you learn from them. But then again, as a trainee, you're still learning. You have to learn what is the basic and what is ideal. Okay? Hindi pwedeng ma-experiment muna. But later on, pag meron na kayong clinical experiences, you will really learn, or you can really modify and learn from it. Again, ito yung inuulit-ulit ko sa aking mga section. You have to learn what is the guideline, what is the ideal. Okay? Sige. Now, examining the sediment. So, microscopic examination, observation of a minimum of 10 fields under both low power and high power. Again, minimum of at least 10 fields dapat ang ating mabasa. Minimum yan. So, it doesn't mean na 10 lang talaga. You can read more than 10, but what is needed is at least 10. When the sediment is examined unstained, many sediment constituents have a refractive index similar to your urine. So, you examine under a reduced light when using your bright microscopes. Again, this is more of your techniques and strategy while using your microscope. So, you learn from this. If a conventional glass slide method is being used, of course, yan yung ating gagamitin, yung conventional glass slide. Your cast have a tendency to locate near the edges of your cover slip. Ito yung sinasabi ko. You look at the side of your cover slip later on. Baka there will be cast na napunta doon. Therefore, low power scanning of the cover slip perimeter is recommended. Okay? Reporting, so we're done with in terms of how do we prepare our smear, the steps, the volume, the centrifugation process, transferring it to the glass slide. Now we will proceed to the last part, which is reporting the microscopic examination. So reporting the microscopic examination, most sediments assessed or enumerated using at least 10 low power field or 10 high power field. Again the minimum na dapat nating basahin is 10 low power field, at least 10, or at least 10 high power field. So, Doc Juan, bakit LPF and HPF? Because later on, you will learn in that in your urinary sediments, some urinary sediments must be read on a low power field, some must be read on a high power field. And again, we have two important steps in reporting, di ba? Meron tayong counted as range, yung kinakount natin, and descriptive, nakikita niyo yan sa urinalysis result niyo sa annual examination, di ba? May nakalagay na few, many, etc. That is your descriptive or qualitative description. And lastly, yung counted as range talaga. For example, 0 to 2, 2 to 5, 5 to 10. For example, your CAST and your RBC and your WBC. These are counted as range. So, naka-range siya 0 to 2, 2 to 5, 5 to 10. So, this is based on a 10 low power field, 10 high power field. Again, your red blood cells and WBC cells are counted in a 10 high power field. Okay, for example, this is one field, right? This is one field. And then you move your microscope on the other side. That's another field. So, from tip to tip talaga yan, guys. Kasi ang nangyayari, paminsan-minsan, lakihan ko ha. Ayan. Lakihan ko pa para makita niyo. Ayan. This is one field, right? This is one field. Ang nangyayari kasi, minsan, ang mga students, they just move the slide, the microscope up to this tip. So, dito lang and up to here. That is wrong because natapos mo na ito nabasa, babasahin mo naman to ulit. So, again, from this one to this one, you move your microscope on another field. So, tip to tip ang ating changes. Okay? This is one field and another field here. Then, you count at least 10 field. Okay? Sige, let's identify. Ano tong cells na to? That is your squamous epithelial cells. Actually, this is in LPO nito. So, this is your squamous epithelial cells. What are this one? Yung yellow dito. That are your WBC. Eh, ano yung nakalagay na pula dyan? Itong mga may pula-pula, that is your red blood cells. Dito ba natin babasahin ang WBC at RBC? Sa low power field? Mali. Of course, hindi natin dito babasahin. Ano nga? Yung WBC and RBC dapat basahin sa high power field. Eh, naka-low power field ito. So again, you have to take note kung ano yung mga sediments na babasahin sa low power field and sa high power field. So for this part, hindi natin pwedeng basahin tong RBC and WBC dito. Okay? Please take note on that. So, ito yung one field. Okay. Dapat at least 10 field. Doc Von, paano ba natin nire-range yung RBC and WBC? For example, nakabasa ka na ng 10 fields. 10 fields, di ba? Ang pinaka-minimum sa high power field. Ika-count, bawat field, ika-count mo siya. Sa unang field, nakabasa, wala kang nakitang WBC. Sa pangalawang field, wala pa rin. Sa pangatlo, wala. Sa pang-apat, may isa. Sa panglima, may dalawa. Sa remaining fields, may tagdadalawa na. So the question is, what will be our range? Are we going to add all the WBC that we counted sa 10 fields? Hindi. Hindi natin siya i-count. I-range natin siya. Yung 0 to 2, for example, dyan, yung 0 dyan is the minimum amount at counted WBC or whatever urinary sediment, pinaka-minimum na count. Eh, di ba, sa example natin kanina, may isang field na wala talagang laman. So, lagay natin ng minimum na 0. Yung 2 naman is ang pinaka-maximum natin na nakita sa isang field out of the 10 fields. Eh, based sa aking example kanina, may dalawa lamang. So, therefore, ang range natin is 0 to 2. Ganyan lang kaisip. We do not have to count the entire 10 fields, but make a range. The minimum and the maximum cells counted per field na nakita natin. So again, dito yung sinasabi ko, past cells, no? 0 to 1, high power field, or your WBC. Take note that your WBC is counted in high power field. Kaya nga, HPF dito. 0 to 1 meaning to say, may field na walang WBC, and ang pinakamataas na WBC na counted sa among the 10 fields is isa lamang. Kaya 0 to 1 per high power field. So, let's have an example. View 10 fields and write down the number of sediments per field. Assessment. Example of assessment of your WBC. For example, yung field 1 natin, 2, field 2, 7, field 3, 5, field 4, 6, etc., etc., go on so forth. Anong result natin? Again, ang pinaka-minimum na na-count natin, 2. So, lagay natin 2. Ang pinakamalaking field na na-count natin is yung field 8, may 8. So, our range is 2 to 8. Again, emphasize ko ha, you do not have to total 8. Ano lang yung pinaka-minimum and pinaka-maximum na nakita natin among the 10 fields. That's gonna be your 2 to 8 high-power field. As simple as that. Okay? Very good. Okay na yan. Alam na natin yan. So, reporting the microscopic examination in practice, the lower and the upper limit of the range must not exceed 10. Again, ang range natin must not exceed 10. Dapat 5 to 10, 1 to 7 must not exceed 10. So, 5 to 10, di ba? Hindi naman siya na-exceed ng 10. 10 minus 5, that's gonna be 5. 1 minus 7, that's gonna be 6. 1 minus 10, that's gonna be 10 minus 1, that's gonna be 9. But 24 minus 3, di ba? Nag-exceed na siya sa 10. So therefore, we could not consider your 3 to 24 and 1 to 15 as a correct answer. Again, the lower and upper limit of the range must not exceed the 10. Okay? Hindi dapat mag-exceed ng 10. Ito, 24 minus 3, di ba? Mag-exceed naman yan sa 10. Dapat hindi sobrang, ang point lang nito is that hindi sobrang layo ng ating range. Ang pinaka-upper limit ng range natin dapat hindi mag-exceed ng 10. Imagine mo, sa isang field, wala kang nakita. Sa next field, meron ka nakitang 100. So, therefore, ang i-report mo is 0 to 100. Will that make sense? It does not. Because remember, anong mali dyan? Hindi mo sinuspend ng mabuti yung ating urine after decantation. Diba? Remember, the main purpose of resuspending, mixing thoroughly is so that there will be pantay-pantay somehow ang ating makikita sa all fields. Kaya nga, nire-require na lang natin at least 10 fields. Hindi na natin kailangan basahin ang entire urine sample natin. Kaya 10 fields na lang, but make sure that it is suspended well or mixed thoroughly. That's the point. Kaya nga, kung exceed 10 na siya, then there's might be a problem in the suspension of your sample. Okay. Ito naman, reporting some sediments, your mucus, your crystals, and your bacteria can be reported in a qualitative assessment. So, descriptive, pwede siyang rare, few, moderate, and many, or numeric term siya, 1 plus, 2 plus, 3 plus, 4 plus, per field of view again. So, again, this will be based on per field of view. So, ito yung mga terminologies natin na you have to take note. Rare, 1 plus, present but hard to find. Few, 1 plus, 1, present in almost every field of view. Moderate or 2 plus, easy to find, number present in the field of view varies, more than few, less than many. Many, 3 plus, prominent, large number present in all field of views. Packed, 4 plus, field of view is crowded by overwhelmed with the elements. So no, this is also now a qualitative and descriptive. Again, this is what we going to report if meron tayong nakikitang mucus, crystals, and bacteria by means of a qualitative term. So again, magdedepende siya sa hospital protocol. Some hospital protocol refer this terminology yung rare, few, moderate. Ito yung ginagamit namin rather than this 1 plus, 2 plus system or numeric terms. Kasi yung numeric terms, usually nakikita natin to sa chemical testing, no? Pero pag mga microscopic examination, we use this qualitative assessment, yung descriptive talaga. Few, moderate. Kaya nga nakita natin dito sa mucus thread, few ang nakalagay dito kasi nga descriptive terms siya. Okay? So again, I want you to somehow memorize this one. No, you have no choice but to memorize yung anong ibig sabihin pag few. Few is isa lang, present in almost every field. Rare, present, but hard to find. Pwedeng may isa lang, pero sa other fields, wala na nakikita. Few, pwedeng may isa or padalawa in almost every field, but not all fields. Moderate, easy to find. Parang meron ka talagang nakikita in all fields. And many, prominent, large number in all field of use. And pack, talagang crowded na dapat crowded na talaga yan. That's your pack. And also, I want you to take note that I have able to learn some strategy and techniques sa aming tawag nito, sa aking staff, senior staff dati sa SPMC when I had my internship there. He taught me on how to properly make a qualitative term description. So for him, ang sabi niya sa akin is we divide the field into 4 4 quadrants. So this is gonna be your 4 quadrants. So 1 quadrant, 2nd quadrant, 3rd quadrant, and your 4th quadrant. So again, you make a cross, then that's gonna be divided into 4 na siya, diba? Kaya na-cross siya, cross. So this is your quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So, i-imagine mo yung mga nakascatter na mga cells. If masakto siya sa isa ka quadrant, therefore that is 1 plus. If masakto siya sa katunga sa imuhang quadrant, sa imuhang entire field of view, that's gonna be 2 plus. If it's 3/4, that's gonna be 3 plus. If in the entire field siya, masakto gid siya tanan-tanan, the entire fields, that's gonna be your 4 plus. That's actually the strategy of my senior. Again, you still have to learn that strategy. You still have to learn ideal. Ito lang muna tayo. You still have to learn this. Base muna tayo sa description dito. Malalearn nyo lang yan when we had our limited face-to-face kasi may imagine nyo siya. Okay? So, this is now the different sediments. Other sediment, your cast, count in at least 10 low power field. Get the average and report the number of cast per low power field. So, you count it. So, again, ang cast natin, remember, cast, RBC, WBC is in range. Madali lang naman memorize. Cast, RBC, WBC, RTE, oval fat bodies, naka-range. Kaya lang, ang cast binabasa natin sa low power field. Ang RBC, WBC, RTE, and your oval fat bodies is counted in HPF. So again, yung cast, RBC, WBC, RTE, oval fat bodies, naka-range siya, naka-count. Kaya lang ang cast in LPF. Yung squamous, epithelial, transitional, and mucous thread is reported in descriptive manner. And it is based on the low power field. Not on the high power, but on the low power field. Yung bacteria natin is descriptive pa rin and based on the high power field. No? Lahi siya, no? Take note, yun na i-take note. LPF for squamous cell, transitional and mucous thread, bacteria for your high power field and may be reported as PAC field. Your yeast, your trichomonas can be reported also in a descriptive manner. Okay? Per high power field also. Okay? Please take note on that. Doc Von, when we do the reporting, Doc ba? Ano yan, Doc? Una, WBC muna ang babasahin ko. 10 fields, WBC muna, pa isa-isa. The next na naman, another 10 fields na naman, RBC. Next field, WBC. Ano? No. Guys, kung anong makikita nyo sa lahat-lahat ng fields na yan, you report not immediately. It will take you time if you are going to report that one by one, right? For example, this one. Diba, dapat 10 fields ang ating i-count. So, take note, kung ano yung nakikita nyo, may squamous ka na, so i-report mo na yan. May WBC ka na, may RBC ka na, so hindi pa isa-isa ang basbasa niyan. Baka sabihin nyo, sabi kasi ni Doc Von, RBC muna, WBC muna. No ha, dapat kung ano yung nakikita nyo sa 10 fields na mga sediments and urinary, i-report mo na siya agad. So, that's why all sediments na natin makikita, mababasa natin siya sa 10 fields para hindi yan ma-consume ang ating time. So, report na muna agad-agad. Okay? Hindi pa isa-isa. RBC, 10 fields. WBC, another 10 fields. Mucous thread, another 10 fields. Hindi. Basahin natin siya lahat-lahat. Okay? Kung ano yung nakikita natin sa buong fields na yon. As long as tama yung reporting natin. Kung for example, yung reporting ng LPF is for mucous thread lang. Of course, doon natin pwedeng ma-report yung mucous thread. Hindi natin siya pwedeng i-report based sa kung ano yung field na. For example, di ba dapat naka-low power field yung ating mucous thread, naka-high power field ka pa so hindi pa pwede. So, again, you can read it as long as correct yung ginagamit natin na field. 10 fields for LPF and 10 fields for high power field. So, ganun na yan. 10 fields LPF, basahin na lahat kung anong pwedeng mabasa sa low power field. 10 fields for your high power field, and also, basahin kung anong pwedeng mabasa dyan. Okay? Please take note on that. And also, we have your sperm cells. Report only if present. Again, this will depend now on the hospital protocols. For crystals, can also be reported on a descriptive manner only per high power field. Okay? Your crystals may be reported as being present or may be reported. Pero siyang crystals present, positive. Pero, they could also be reported as rare, occasional, moderate, and many. Again, this will now be depend on the hospital protocol. Pero sa amin, usually, ito talaga yung few, moderate, etc., etc. We also have this what we term as your too numerous to count or yung sinasabi natin na pack field. Diba yung pack field natin? 4 plus. Diba? Pack field is 4 plus. So, ito yung minsan nilalagay namin 2 numerous to count. Diba nakikita nyo? TNTC pag nakalagay sa reporting. No standard rule of this, but in practice, if there are more than 30, high power field can be reported as TNTC. So, meaning to say, more than 30 na. For example, you in a high power field, nagbabasa ka ng RBC count, sobrang daming RBC count. So, therefore, kung more than 30, we already say that it is already TNTC or packed field. Or meaning to say, kung numeric siya, 4 plus. In the field is packed with overwhelming sediment, usually applied to RBC, WBC. In bacteria, report as packed field. Of course, sa bacteria, hindi kami naglalagay ng two numerous to count. Usually talaga no, sa RBC and WBC siya, yung TNTC. But in bacteria, we report that as many, but not packed field. Okay? So ito yung sinasabi ko. So this is already in your, tawag nito, in high power field, sorry. So as what you can see, these are your WBC. Sobrang 30, more than 30 na ito, 'di ba? And ang sabi ko, 'di ba, yung TNTC is 4 plus, right? 4 plus siya. So 'di ba, yung tinuro sa akin na stuff is somehow correct kasi nga if you make a cross on this one, 'di ba, parang the entire field is na nakikita natin. So in short, this is already 4 plus. Same with here. These are your RBC, more than 30. Count nyo siya. 1, 2, 3, 4, 5. Madami. More than 30. More than 30. So makikita nyo sa reporting, there is already 2 numerous to count. Do not worry when we have our limited face-to-face. Hopefully, you can learn and you can see the correct way of the description, anong strategy. Tuturuan ko kayo sa aking strategy. Okay? So, urine, this is now the summary of what we discussed a while ago. Your factors that require standardization in a microscopic exam, urine volume use, ito, speed, the time, yung concentration of sediment prepared, we usually do not do this because commonly ginagamit ito sa commercial system, the volume of sediment examined, and the results and reporting. Okay? So, for your laboratory output, for you to memorize kung ano yung dapat nire-report sa low power field, sa high power field, ano yung nire-report sa ating as range, ano yung nire-report as numeric or descriptive, I want you to list down all these urinary sediment para mas ma-memorize niya. Para if naka low power field na kayo, alam nyo kung sino lang i-arrange, alam nyo sino ang numeric. Memorize natin. Pag high power, alam nyo na rin. Okay? So you list down all these urinary sediment and submit this sa ating canvas. The instructions is already written there. Okay, this is only a very short discussion that ends my lecture video. I hope you learned something from today. Do not worry, mapapractice natin to when we have our limited face-to-face next month. I am very excited. See you soon in SPC. God bless you guys. Thank you, everyone.